large language models are. Well, they're truly incredible these days. Writing code, poetry, summarizing huge documents. The list just goes on.
It really does. The capabilities are astonishing.
But there's this kind of core challenge,
Yeah.
right, baked into how they work. Once they're trained,
Right.
they're static,
Exactly. They don't just naturally learn or adapt to new stuff once they're out in the world.
which is a huge bottleneck, isn't it?
It's a profound one, yeah. It means without us constantly stepping in, retraining them, feeding them new data, they can't grow their knowledge or improve their skills on their own.
It's like this amazing library that's built, but then you can't add any new books unless you basically rebuild the whole thing.
That's a great analogy. Rebuild it from scratch, essentially.
So what if that wasn't the case? What if these models could actually, learn to teach themselves?
Now that's the interesting question.
And that's exactly what we're diving into today. We've been looking at this really groundbreaking framework called self-adapting LLMs, or SEAL.
Mhm. It comes from researchers at MIT, Adam Swiger, Geoffrey Parry, Han Guo, Aiken Akirek, Yoon Kim, and Pulkit Agarwal.
And it presents this vision of, well, genuine autonomous learning for AI.
The core idea, the real innovation with SEAL, is giving the LLM the power to generate its own fine-tuning data and even create its own instructions for how to update itself.
So back to your library analogy.
Yeah.
It's not just getting new books delivered.
Right. It's like the library deciding, okay, I need information on this topic, then writing those books itself and figuring out the best way to slot them into its existing knowledge.
A shift from just consuming information to actively directing its own learning.
Precisely, self-directed knowledge acquisition.
So our mission for this deep dive is pretty clear. We want to unpack how SEAL actually turns these static models into self-teachers.
Yeah, look at where it's already working, and maybe surprisingly well.
And then touch on the limitations, of course, but also the really exciting possibilities this opens up for AI down the road.
Sounds good.
Okay, so this fundamental challenge, keeping LLMs current, letting them grow. SEAL introduces this concept of self-edits. What exactly are these self-edits? How do they make a static model dynamic?
Right. So self-edits are basically instructions written in natural language that the model generates for itself.
Like little memos to itself?
Kind of, yeah. Sophisticated memos. They can tell the model how to, say, restructure information it just received, or even specify technical details like what optimization settings to use for learning.
Uh-huh.
And crucially, they can tell the model to use external tools, maybe for data augmentation, or to trigger its own weight updates using gradient descent.
So the model is directly controlling its own learning process.
Exactly. That's the key difference. Before, you usually needed separate external systems to manage the adaptation. Here, the model's in the driver's seat.
Okay, so it's not just passively getting data, it's actively making its own study materials and its own strategy for learning. That's really clever.
It is.
But how does it learn to make good self-edits?
Yeah.
Feels a bit like a chicken and egg thing.
Right. That's the million-dollar question. And this is where reinforcement learning, or RL, comes into the picture. SEAL uses this really interesting two-loop system.
Two loops, okay.
Yeah, so there's an outer RL loop. Its whole job is to train the model to generate effective self-edits.
How does it do that?
Well, the model performs an action which is generating one of these self-edits. Then it essentially gets a reward based on how much better the model performs after applying that edit.
Ah, okay, so the outer loop is about figuring out the best strategy for adaptation. Makes sense. But how does that strategy actually, change the model? Where does the actual learning happen?
That's the inner update loop. This loop takes the self-edit that the outer loop produced.
The instruction.
Exactly, the instruction. And it uses that to actually update the model's internal weights, typically through supervised fine-tuning.
Got it.
And then the RL part, back in the outer loop, refines the strategy for making edits to try and maximize that future performance boost.
So it learns which kinds of edits lead to good results.
Precisely. They found an algorithm called RayStem. Worked particularly well here. It basically reinforces only those self-edits that demonstrably lead to better performance.
Smart. It learns to ignore edits that don't actually help.
Yeah, it focuses the model on changes that really move the needle.
Okay, so we've got a handle on the mechanics now, the sort of dance between the model writing instructions for itself and then getting rewarded for the good ones.
Right.
But the real proof is in the pudding, right? What can LLMs actually do with this? The research highlighted two main applications. Let's start with getting models to absorb new facts, Knowledge incorporation.
Yeah, knowledge incorporation. The idea here is you give the model a passage with new information, and you want it to really internalize those facts.
So it can answer questions later without needing to see the passage again.
Exactly, which is traditionally tricky for LLMs. They often just retrieve info. SEAL tackles this by having the model generate what they call implications from the passage.
Implications.
Yeah, think of them as concise summaries of the new facts and how they connect. These implications then act as synthetic or self-generated training data.
That sounds really neat, generating implications as training data. But how do they know if those implications are actually any good? Like, are they useful or just random sentences? And did it actually work?
Good question. They tested this using the Quen 2.57b model on the Squad dataset.
Yeah.
In what they called a single passage setup, the base model with no adaptation got around 32.7% accuracy on questions about the passage afterwards.
Right?
SEAL boosted that to 47.0%, which is a solid improvement.
Definitely.
But here's the really interesting part. They compared SEAL's self-generated data against synthetic data created by GPT 4.1, a much, much larger model. And SEAL's data actually led to better performance. GPT 4.1's data only got the model to 46.3%.
Wow. So the smaller model teaching itself did better than getting notes from the huge expert model.
Essentially, yes. It suggests the model is becoming a more efficient, more self-directed learner. It's figuring out what it needs to learn better than an external system can dictate.
That's impressive. Did it hold up over time, like with more information?
It did. They also did a continued pre-training test, feeding it 200 passages. SEAL still came out on top at 43.8% accuracy, showing that the self-editing policy it learned seems to generalize pretty well.
And the RL part, the reward system, was key.
Absolutely. They found RL training consistently added between 6 and 11 percentage points to the performance, regardless of the exact prompt style they used, like asking it to rewrite or do self-QA.
Okay, so knowledge incorporation looks promising. Now, the other area you mentioned was few-shot learning. This is a huge deal in AI, getting models to learn from just a couple of examples. How does SEAL help there?
Right. Few-shot learning is notoriously difficult. For this, they used a simplified version of the ARC benchmark that's the abstraction and reasoning corpus. It involves figuring out visual patterns from very few examples. Normally, for a new task like this, a human would have to painstakingly figure out the best way to maybe augment the limited data or tune the training parameters.
Oh, lots of manual fiddling.
Exactly. But with SEAL, the model autonomously generates self-edits that configure its own adaptation process for that specific task.
So the self-edits aren't just about facts, they're about how to learn.
Precisely. They specify things like data augmentation strategies. Should it rotate the images, flip them, resize them, maybe chain transformations together, and also optimization details like the learning rate or how many training epochs to run.
Whoa. So the model is basically choosing its own study method, tweaking its own brain based on just those few examples. That sounds incredibly advanced.
It's a significant step, yeah.
What were the results like on that ARC task?
They used a Llama 3.2 1B instruct model. SEAL achieved a 72.5% success rate.
72%. How does that compare?
It's a massive leap. Standard in-context learning, just showing the examples in the prompt, got 0%. Zero. And even a technique called test time training, but without SEAL's RL-based self-editing beforehand, only managed 20%.
So SEAL isn't just adapting, it's learning how to adapt effectively from almost nothing.
That's exactly what it demonstrates, the ability to learn how to generalize from really minimal information.
These results are genuinely impressive. 47% on Squad, over 70% on IRC. Okay, let's talk reality checks. No new tech is perfect. What are the limitations? What challenges did the researchers find with SEAL?
Yeah, it's crucial to look at the hurdles. One major one they discussed is catastrophic forgetting.
Ah, yes, the classic AI problem.
Right. SEAL allows for lasting changes, adaptation, but when the model keeps making these self-edits, incorporating new stuff over and over...
It might start forgetting things it learned earlier.
Exactly. Its performance on older tasks can sometimes decline. It's like you become fluent in Spanish, but then suddenly struggle to order a pizza in English.
Does it completely forget or just get worse?
The research showed it doesn't completely collapse, but performance can definitely degrade. So, true continuous learning without losing old knowledge, that still needs work. Maybe specific mechanisms to penalize forgetting or different update strategies.
So that's one challenge, retaining knowledge. What else?
Another pretty significant one is the computational cost. Calculating that reward for each self-edit, it's intensive.
Why is that?
Because you have to actually apply the edit, which means fine-tuning the model,
Yeah.
and then you have to evaluate the model's performance afterwards.
Ah, okay. So each potential edit requires a mini training run and test.
Pretty much. They reported each self-edit evaluation took something like 30 to 45 seconds. And a full round of training the outer loop, the part that learns to make good edits, could take about 6 hours.
On what kind of hardware?
On 2 H100 GPUs, which
Yeah.
are, pretty serious top-of-the-line AI processors.
Okay, so definitely not something you're running casually on your laptop just yet.
Yeah.
Significant compute required. And you also mentioned something about the evaluation being context dependent. What does that mean practically? Does it need human help for evaluation?
Yeah, that's another current limitation. Right now, SEAL assumes that whenever it gets new information, it also gets a predefined task or a set of questions to evaluate its learning against.
So it knows what good looks like for that specific piece of info.
Exactly. Which makes calculating the reward much easier. But it also means SEAL can't really learn from just raw, unlabeled data flying by. It needs that evaluation context.
Is there a way around that?
Well, the hope for the future is that the model could learn to generate its own evaluation questions or test cases directly from the new content it encounters.
Ah, so it could test itself, essentially.
Right. That would allow it to learn in much broader, more unsupervised scenarios. Truly self-sufficient learning.
Okay, connecting this to the bigger AI picture, it feels like SEAL is addressing some really fundamental issues. The paper mentioned an impending data wall. What's that about, and how does SEAL fit in?
The data wall is this projection, you hear quite a bit now, that sometime around 2028, maybe sooner, maybe later, the big frontier LLMs will basically have been trained on almost all the high-quality public text data available on the internet.
We'll run out of human-generated training data.
Essentially, yes. Or at least the rate of new high-quality data won't keep pace with the model's appetite. Once we hit that wall, progress might really depend on a model's ability to generate its own useful training signals.
And that's where SEAL comes in.
Exactly. By enabling models to create their own synthetic data, their own implications, their own learning strategies, SEAL offers a path forward. It lets models become more self-sufficient learners, potentially pushing beyond the limits of existing human data.
So you could genuinely imagine a future where an LLM, say, reads a new scientific paper. And then it doesn't just summarize it. It generates its own deeper explanations, figures out the implications, creates questions about it, and then uses all of that to update its own internal knowledge.
That's the vision, that iterative loop. Self-expression, self-questioning, self-refinement. It's a powerful idea for truly autonomous learning.
It sounds like it could have big implications for AI agents, too.
Absolutely. Think about agentic systems, AIs that need to operate over long periods, interact with the world, pursue changing goals.
Yeah, they need to adapt on the fly.
Right. SEAL could potentially allow these agents to incrementally learn and retain knowledge from their experiences as they act, continuously improving their behavior without needing constant human handholding or retraining.
Could it even connect with how models reason?
That's another fascinating possibility. Maybe an LLM, while it's working through a complex problem, could decide mid-reasoning that it needs to update its own weights based on some insight it just had.
So it could sort of distill a complex thought into a permanent change in its capabilities.
Potentially, yes, turning temporary reasoning steps into lasting improvements. It suggests a real synergy between reasoning and learning.
What really strikes me here is how SEAL shifts the whole picture. We tend to think of LLMs as these vast but ultimately fixed libraries of information.
Right, static repositories.
But SEAL seems to be pushing towards something more dynamic, something self-improving. It feels like a really significant step towards models that don't just know things, but can actually learn how to learn.
I think that's right. By generating their own training data, guiding their own updates, they start to take ownership of their learning process. It's about building that foundation for more truly intelligent systems.
Systems that can keep getting smarter even when we run out of new data to feed them.
Exactly. Scaling intelligence in what might become a data-constrained world.
And that really leaves us, and you listening, with a pretty deep question to chew on. If LLMs can genuinely learn to teach themselves, how might that fundamentally change things? Not just how we build AI, but maybe even how we as humans think about learning, about knowledge, and how we acquire it in the future.